Hello all, my name is John with DeLong Rigging Solutions. When a show comes into a venue and the head tour rigger takes chalk or maybe puts stickers down on the floor where things need to be rigged overhead, he tells us what size chain hoist and where it needs to go as far as the physical location on the floor. And it's often the house lead rigger who needs to take that information from the floor and decide what wire rope combination is necessary to attach it to the structure. There are many factors involved: load factors, how heavy the load is; dimensional factors, the length of hardware needed to correctly position the load; and logistical factors, as in how we're going to get that hardware installed and lift the load into place safely. Let's look at a plan view of the task. So if the rigger has come in and they've marked circles on the floor to show where they need a hoist at. So we're gonna read that as 1-ton hoists. We have some that are directly under the structural steel and some that are not. These dotted lines represent where there is structural steel over the stage, and the rectangle there is our stage. For this point that's directly under the steel, that's what we would call a dead hang. Dead hang meaning that it's going to hang vertical and plumb. We're not going to have to pull it sideways any. So for a dead hang, the process of determining how much wire rope we need is pretty simple. Let's say our chain hoist to have 50 foot of chain. And it's 80 feet from the floor to our structural steel. These I-beams here represent this structural steel over the stage. And in this elevation view, we can see that it's 80 feet from the floor to the steel. If we have our hoist down here and our hoist has, let's say that our hoist has 50 foot of chain. If we have 50 foot of chain, then we need another 30 foot to get us up here to the steel. Let's say, and this 30 footer is what we would call the down hang or the stinger. And at the top of that 50 footer, we're going to put a 5-foot basket. That 5-foot basket is the cable that wraps around the steel. And it would come to a loose shackle here that we call the connection shackle or the working shackle. So to make this dead hang, we have our chain hoist and 50 foot of chain. We have a 30-foot down hanger stinger. And we have a 5-foot basket cable to wrap the steel. And there will be a loose shackle called the connection shackle. So that's it for a dead hang. It's pretty basic. All we have to do is calculate the length of the chain, how much additional cable we need to reach the steel, and then what size cable we need to wrap the steel. When your point is between the beams, then we have to do a little more work at it. This one here looks to be pretty much centered between the beams. Let's say that it is exactly in the middle between the two beams. That's what we would call an even-legged bridle. For an even-legged bridle, it's still pretty simple. Let's draw it in here real quick. So for that point that's evenly spaced, let's say it's right here. There's our mark on the floor. We've got our same 50-foot chain. So we've got 50 foot of chain to work with. If it's an even bridle, a good building block to work with is our space between our two beams, or our span between the two beams. Let's use that same 20 foot and say that our bridle is going to be 20 foot by 20 foot. Because it's an even bridle, because it's right in the middle, we know that they'll both be the same. They'll both be 20 foot. And our span between is a good building block to work with as long as we have enough height. So let's say that we're going to have our 20 foot our 5-foot baskets. And then we still have a gap here. This is called the apex of the bridle. And this cable that comes down from the apex is called the stinger or the downhang of the bridle. In this case, we know that we got 50, and we had 20, but our 20 is out of plumb. It's not vertical. So since it's out of plumb, we're going to lose some of that height as we push it sideways. So I think we're going to need, if we had 10 foot, that'd be our 80, but I think we need 15 here to make sure that we have enough, because we don't have a full 20-foot vertical. So if we make our stinger or our downhang on our bridle 15, and we know that we have at least 20, would be 35, and 50 would be 85. So that gives us a little extra to account for that swinging out of plumb. So in this case, for an even bridle, we would have 2 even legs, a 20-footer and a 20-footer. Our basket cables, we're calling them 5-foot basket cables for these beams, and our 15-foot stinger to attach to our 50-foot chain. And that would give us an even bridle. If our point is not in the middle, it's not right in the center. Let's say that it's 12 foot from this side and 8 foot from this side. Now we've got to do a little more calculation, a little more math to figure out how long those bridle legs are going to be. We'll still work with our same 50-foot chain, but it's not going to be right in the middle this time. So we'll have to do a little bit more work here to figure it out. There are a number of software solutions for phone apps, and some of those work pretty well. However, it's still best if you understand the process of how that software works and what it does. In this case, I'm going to say that my point is 12 feet from one side and 8 feet from the other. So if I draw my span here of 20 feet, and I draw from the apex of the bridle up to that line. Now I've made 2 right triangles here. Now I can use those triangles to help me figure out the length. If I'm 8 feet from that side and 12 feet from that side, I'm going to use a 20-footer again. I'm going to use that same number, the span between the beams, as my building block for my bridle leg. So on the side that's closest to it, I'm going to say that I'm going to use my 20-footer there. So this becomes my unknown. This is my bridle leg that I'm in search of. Let's call that, we'll call that the left side of my bridle, or L2, and this would be L1. But we already have a number for this side over here. Now we can also know that we still have our same 50-foot chain. We have our 20-foot building block. So I'm going to say that our stinger is still going to be 15. We don't really have to do very much additional calculation to figure that out. We still got 50-foot of chain, 15-foot of stinger puts us at 65, and 20 will be 85. So we've got the height we need plus a little extra. But we still need this other bridle leg. So for that bridle leg, we're going to use what's called the Pythagorean Theorem. I'm sure that in some geometry class somewhere, you've probably seen a squared plus b squared equals c squared, where a and b are the sides of the triangle, of the right triangle. So this is a right triangle, that's a side, that's a side, this is a hypotenuse. So that's our C. And what we're looking for here is C, or our hypotenuse of our right triangle on this side. So first thing we have to do is figure out this length here. So we have two sides of this triangle. We can calculate that one. So if this is a side and this is a side, it will be 8 squared plus, let's call this H. That'll be our height of our vertical part of the triangle there. So 8 squared plus H squared equals C squared, and our C is 20, so that's 20 squared. So we get 8 squared is 64 plus H squared is equal to 20 squared is 400. So that gives us, if we do a little bit of algebra here and get all our knowns on one side and our unknowns on the other. So H squared is going to be equal to 400 minus 64. So H squared is equal to 336. And H is going to be equal to the square root of 336. H then, I have to get the calculator out for this because I can't do that one in my head. I'm going to use the calculator on my phone. I've got a scientific calculator on here. It doesn't have to be a real fancy calculator, but it does have to be able to do square roots. So I'm going to do 336, and I want the square root of 336 is 18.33. All right, so H is equal to 18.33. Now I have two sides of my other triangle. So now I have a way to calculate L2, or the length of the other leg of my bridle. So to do that, I'm back to A squared plus B squared, but my sides of my right angle there are 12 and 18.33. So I'm going to have 12 squared plus 18.33 squared is equal to my L2 squared. And 12 squared is 144. 18.33 squared, I happen to know, is 336, since I just worked with that, is equal to my bridle leg squared. So the square root, or if the L is going to be equal to the square root of 144 plus 336, which is going to be 480. If my math is right here, 300, 470, 80, yep. Square root of 480. So L then, back to my calculator, is going to be the square root of 480, is going to be 21.91 feet. I don't know what 0.91 feet is in inches. I guess I can find that out pretty easy. If I take 0.91 times 12 inches, so it's going to be about 11 inches, not quite 11 inches. So this leg of my bridle here is 21 feet and 11 inches. So to make that up, I'm going to use something called a deck chain. You may be or should be familiar with the deck chain if you do any of this kind of work. Deck chains are typically, I think it's 3.74 inches. So looks like 4 times 3.74. Yep, that's not enough. Let's try with 6 links. And yeah, that comes out about right. So that'll make our bridle then, this leg of our bridle will end up being a 20 plus 6 links to make it 21 foot 11 inches, or as close as we can get to 21 foot 11 inches. So that's the process that we would go through if we were doing this manually, just figuring out the math, not using any software and not guessing at it. If you get some experience and are able to guesstimate pretty well, you might not have to do all the math, but your guys in the ceiling might appreciate it if you do the math and get it right the first time. Another thing to consider, not just the accuracy of the calculation, but just some general guidelines to think about, is when we're starting the process of determining bridle legs, of calculating the bridle legs, some things that we think about. We've been talking about using the span of the bridles as a building block, and that's a good thing. One of the reasons why we do that is that if you use the span, that 20 foot across the top, as a building block for your bridle legs, say for the equal legged bridle, when you do that and your bridle legs are the same length as your span, that creates what's called an isosceles triangle. An isosceles triangle has 60-degree angles all the way around. And that's a real comfortable bridle angle. We don't, anytime we're doing bridles like this, one of our concerns is to not create a tremendous amount of horizontal pressure on the two beams. At that 60 degrees, we're in a pretty comfortable area as far as those horizontal loads. Our goal, one of our goals, we'd always want to see them 45 degrees or greater off of horizontal. If at 45 degrees, another way of looking at this or saying this is that at 45 degrees off of horizontal, our apex of the bridle is at 90. So even on bridles that are off center, we would still like to see this angle here at the apex be 90 degrees or less. The extreme for a bridle, say we have a bridle that's off center, and we do a bridle like this, where that bridle is way flatter than 45 degrees. It's way less than 45 degrees off of horizontal. But this bridle here, or this angle here, is still pretty close to 90. Our maximum that we ever want to see here is 120 degrees. And we don't really want to see 120 degrees in an even bridle. We don't want that. We don't want that up at 120. We'd like that at 90. The 120 really comes more into play for a bridle that's off center. We use that 120 because the specifications on most screw pin anchor shackles, if you can look up the manufacturer's specs, 120 degrees is the max that most shackle manufacturers will give for a side pull on the bell of the shackle. So those are just some basic guidelines, some rules of thumb that we use to keep our bridle legs at 45 degrees or more off of horizontal, or the apex of the bridle, thinking of it in a different way, the apex of the bridle should be no more than 90 degrees between the two legs. Please remember that DeLong Rigging Solutions one-shot training videos are meant as general information. Every system is different, every venue has different procedures, and even the same show in a different place has different needs. All statements made make certain assumptions about systems and venue similarities. Nothing can replace on-site training with a qualified individual. If ever you have a question or concern about rigging, Do not hesitate to reach out to us or another qualified vendor in your area.